What's up, everyone, and welcome back to the series on computers, on data science, and on Python programming. In this video, we're going to do some more extension of lists, and then we're going to go into operations on tables. So without further ado, let's check out this list of lists. Remember, this is still with the emoji unit we were working on last time. It just gets a little bit more complex. So let's see. Plain lists allow us to transfer individual table columns into Python, which provides us with interesting results. In order to analyze it thoroughly, we need a list of lists. We'll create a list with a single string from the table above, excluding the symbols, since we don't need them anyway. The string for grinning emoji is now saved in the variable grinning row. Okay, so they've created one list here. Now they're going to compile a data list from several variables at the same time. So now they're making a beaming row and a raffle row, and they're storing all three of those lists in a new list called data. So when they print it out, you'll see you have a list because it's the outer square bracket, and you have an inner square bracket, which is the single list that's inside it, and another list, which is beaming, and another list raffle. The table strings don't have to be saved in a variable first. They can also be presented like so. So here they're not even putting them in variables. You can put a bracket or a square bracket and then another square bracket and do one list, do another square bracket, do another list, and another square bracket, and so on. Okay? Structures like this are often referred to as nested lists. When brought together, they produce a table. When referring to elements from a table such as this, you'll have to use two indices. The first index indicate the string and the second indicating the column. Let's try to extract the quantity of the beaming emoji, string index 1 sent on Twitter, column index 3. Okay, so this is also referred to in what I'm familiar with as two-dimensional arrays. So you can think of this as like a 2D grid, right? Like in Battleship, right? If you say A2, would be like the column, and then 2 would be the row. Okay, so let's look at the task here. Add 2 more strings to the data table for tears of joy and winking emojis. Okay, so they want us to write code here. We're going to do tears of joy. Oh, tears on joy, lol. Tears of joy, comma. And if we look at the table, it's probably at the top here. Tears of joy has 233. Is that the number they want? Let's see what they did for grinning. Grinning 2.26. Yeah, they want this big tears of joy to be 233. And then 7.31. And then 2270. And that's it. So we don't need that last comma. Okay, so then we need another comma because now we're doing another list within that list. So tears of joy, and then they want winking. Ooh. Okay, so if we scroll to winking in this table over here. Oh, I went back by accident. My bad, guys. That touch pad will get you. Luckily, it saved what we were doing. Scroll down. Winking is 15.2. 2.36. 264. That's it, right? So we don't need that last column, comma. All right, so does it want us to print it? No, it just says to add 2 more strings to it, so let's check. Correct. All right, number 2. Now use the double index reference method in order to obtain the quantity of the tears of joy emoji on Instagram from the table and print the result on the screen. Okay, so the double index reference means you're going to do data at, let's see, tears of joy is 1, 0. So you should always do 0 base, right? So tears of joy is 0, 1, 2, 3 is the row. And Instagram is 0, 1, 2. Okay, and they want us to print that. And this is actually the wrong way I did this. I think you do it like this, right? So what's happening is I'm accessing the first list via the first square bracket, which should access the third thing here, which is 0, 1, 2, 3, Tears of Joy. And then once I have this access via that first bracket, I'm getting the second index, so that's 0, 1, 2, which should be 7.31. Let's see when we play. 7.31. Okay, so let's hit next. Oh, whoops. I was supposed to hit next again before. I do that a lot, don't I? Okay, so we had data at 3.2, right? Should get 7.31 if I did that. Yeah, okay, so let's check. Correct. Next. Lists of lists in loops. Wow, they gave us a big array there. Let's see if there's a description for this one. Lists of lists can also be processed using loops. First, let's print every table string for the top 5 positions. Earlier, we used the double indices to access cells. The variable row in a loop already contains the string order, which is why we don't need a string index. For example, in order to obtain the name of an emoji, we'll select the index of column 0. You can also access other columns as well. For example, index 1 stores the quantity of emojis on Emoji Express. First, keep in mind that the print function can print several values into a string separated by spaces if you pass arguments separated by commas. They already taught us that. Look, we've printed our first table. It's incomplete and not perfectly aligned yet, but we'll fix those problems in the following lesson. Okay, so finish the code so it prints the whole table in the following format. Okay, so we already have emoji name, bar, emoji express, comma, mil, period. Let's see. Why didn't they put Instagram mil in there? I think we're supposed to add that. These are just examples, I guess. So then we have bar, vertical line, Instagram, comma, mil, period, bar, Twitter, comma, mil, period. Okay, and then they have the... Hopefully that's long enough there. Then we print row. So we want comma, quote, vertical bar, comma, row 2, comma, vertical bar, comma, row 3. All right, I think that's right. Okay, let's see. Correct. Aligning text. Finish the code. Oh, I guess we should read the description here. Our tables are now complete, but they haven't been properly aligned yet. Of course, it would be much more convenient if it looked like this. It looks weird because there's not enough space there. Look, all the cells are of equal width. The names are aligned to the left, making them easier to read, and the numbers are aligned to the right, making them easier to compare. We've achieved this by calling the format function. This is how we indicate that we'd like to print the results in 20 symbol wide sections. Fill in the blank areas with spaces and align the text to the left using vertical lines added to designate the cell borders. Here is the template structure for the format function. You can fill the blank space in the cells using other symbols like dashes, for example. The symbols less than, greater than, and caret respectively mean aligned to the left, right, and center. If you first designate an alignment method followed by the method to print fractional numbers, then both shall be applied. This is interesting. I've never actually done this previously, so this will be different. Finish the code so that the text is output like this. In a cell 15 symbols wide, aligned to the right with blanks filled by spaces. All right, so they said the alignment should be to the right. Okay, and they said to the align to the right, so it should be like this middle one. You should, let's see what the difference is here. Use this greater than sign. Okay, so they want bracket colon greater than, and then the number of spaces, which is 15. They want the number of decimal points, which doesn't look like that matters here. Colon space 15. See what it looks like. Check it. Correct. Task 2, finish the code so that the number is as follows. Line to the left, so it should be a less than sign this time. And then we want, what was it, 12 spaces dot 2f. That's out of order, but those are the three things, right? It should be dot 2f 12. I'm missing a colon, that's it. They have them all crunched together, even though they said you should put spaces. I don't know. I don't know how that best would look. Let's see. Rounded the 2 decimal. Yep. So let's see if that's right. In a cell 12 symbols wide, aligned to the left. Looks like it's aligned to the left. With blanks filled by spaces. Guess we didn't put the space here like it once. There we go. Okay. Now the third task is now update the code by printing the entire table by adding the alignment and the number output rounded to the second decimal place. Each column has a set width that allows every value to fit inside. We've already added a header with the correct width to the pre-code. From this you can obtain From this table, you can obtain the width for the columns to be included in the template for the format function. So emoji name is 16, emoji express is 16. Okay, so we want to print and we want the format to be for the emoji name to be 16 wide, which is, do they want the oh, here we go. It wants us to do this. Okay. And so the first one is 16 wide. Colon less than 16 did I say how many decimal places? To the second decimal place, .2f. Okay, and then I'm just going to copy for these other ones. I also didn't put spaces. You got to put a space in between it. Oh. Okay, and the only one that's, or the last two are different. The last, or second to last one is 14 instead of 16. And the last one is 12 instead of 16. So we hit play. These should be aligned now. Moment of truth. Unknown format code F or type string. So I probably got something out of order. Let's see what the print statement looks like. We have squiggly bracket colon space less than sign 16.2f in bracket. Unknown format code F. Oh, you can't have a float. Which one's a string? I think the first one is, right? So we don't need an F for the... Let's see. Right, because it says loudly crying. That's not a number, so you're not trying to... Everything looks right except the first row. We didn't do the first row, so let's see if they like that. Check the second template. It should be greater than... Okay, so I don't know where it said that, but we'll do that. That's fine. Are all of them supposed to be like that? Probably. Correct. I don't know what they're doing on this first row, but it's messed up. Okay. Okay, string and list length. The values differ greatly from platform to platform. For example, on Twitter, raw numbers are incredibly large. In order to confirm this difference, let's count the average quantity of emojis from the top 20 positions from Emoji Express, Instagram, Twitter. Mean values can be calculated by using the following equation. Mean equals sum over quantity. We already know how to calculate the sum of the values, and now all we have to do is calculate the length of our list. The function length can be applied to any list in order to calculate its exact length. We can also calculate the length of strings by using the length function. Now you can simplify the calculation of columns width in order to format your outputs. Okay, so we scroll down. What is the mean value of the messages in millions sent with all of the top emojis on Emoji Express combined? Print the results to 2 decimal places. In order to add the values, create the variable sum emoji express and store the mean number in the variable mean emoji express. Okay, so so we make a sum emoji express. That's going to be equal to 0 initially. And we have mean well, I guess we can calculate that at the end. All right, so we have for element in the list, which is data. For each element in the list, we're going to make the sum emoji express equal to let's see. I know how to do this with 2 loops, but I don't think we're supposed to use 2 loops. So, oh, it's the first index. Okay, so this is equal to data, or actually element is a list, right? So we want element at position 1, right? Because 0 is the name and 1 is the emoji express value. Okay, so now we have the sum of all the emoji expresses, and then we want the mean, which is going to be mean emoji express. So let me like iterate what this is doing. Okay, so this is going to go into this data list, and it's going to assign element to this first list, right? It's going to be this whole thing, right? And then what we're going to do is we're going to grab the value at element 1, which is grinning would be element 0, 2.26 would be 1. So we're going to take 2.26 from this first one and make that part of the sum. Then the list is going to, or the for loop is going to go to the next item, which is going to be this beaming list. So now this is what element is equal to, and we're going to get the first element of that. So it's not going to be 0, it's going to be 19.1, okay? And so we do 2.26 plus 19.1, then we're going to add 25.6, then we're going to add 233.0, and so on, and that's going to be our sum. Now to get the mean, we need to divide by the total number of elements here, which is going to be the length of data. So we're going to do sum emoji express divided by length of data. Okay, and it wants us to print that. Nope, it just wants us to calculate it. So let's see if that's correct. Check. Oh, it does say print. Print the results to 2 decimal places. Okay, so we need to do print with the quote, and then we need the bracket dot 2f. Is that right? And then we do dot format mean emoji. I misspelled it here too. Emoji express. Let's run that, see if it actually prints it. Float object has no attribute .2f. So I'm obviously formatting it wrong here. Dot format. I'm forgetting how to do the formatting here. So if we do this, hit play. Okay, that's going to give us the full number. but we want to 2 decimal places. So I think you would have to do 0.2. All right, I'm going to cheat and look it up. Format to 2 decimal places, Python. You should know this from the last lesson we did. I just don't remember. Here we go. Oh, I just forgot the colon. Stack Overflow is your friend for the future. Oh, and 2F. Nice. But I made an error somewhere. All right, so let's print Emoji Express, or let's print some of Emoji Express. So the sum is only 0.33. No, that's only the last one. Oh, it's got to do plus equals. Plus equals, not equals, guys. All right, that should work, right? Check it. Correct. Next. Now calculate the mean values for the other platforms. Store the results in the variables mean Emoji Express, mean Instagram, mean Twitter. We've already wrote the code for printing the outputs in visually appealing format. Cool. Okay, so we did a mean Emoji Express equals this. So we want sum of Instagram to be equal to 0 originally, the sum of Twitter to be equal to 0 initially, and then the only thing that's going to change here for Instagram is it's going to be a different index. It's not going to be 1, it's probably going to be 2. Let's make sure that it's number 2 in the columns. So Emoji Express is 1. So name is 0, Emoji Express is 1, Instagram is 2, and Twitter is 3. So then we're going to add for Twitter plus equals row 3. Okay, now we need to take... I don't know why they put the mean in the wrong indentation there. Mean Instagram is going to be sum of Instagram divided by length of data, and mean Twitter is going to be sum Twitter divided by length of data. Okay, so let's play, see if we get something good. Suam Twitter, would I write that at? There we go. Typos, they'll get you. And then it only printed... Nope, it printed all of them. Let's see. Aha! Next. Analyzing column relationships. In the previous lesson, we've calculated the following ratios for emojis on 3 different platforms, the mean values. As you can see, the user posted about 100 times more emojis on Twitter than on Instagram. Does that ratio hold equally true for all emojis? For each emoji, calculate the ratio of its quantity on Twitter compared to its quantity on Instagram. Print the result on the screen in the format below with all the given values rounded to 2 decimal places. Okay, so for row in data, they want the emoji name and then the Twitter Instagram ratio. Okay, so Instagram, I guess we should do Twitter first, huh? Twitter is equal to date row at which number? So zero's name, one's emoji, or zero's name, one is Emoji Express, 2 is Instagram, 3 is Twitter. Instagram is equal to row 2. Okay, and it wants us to print the ratio here, which is going to be Twitter divided by Instagram. Two-pole out of range. Let's ratio equals Twitter divided by Instagram. Print ratio. And here we'll just put ratio, see what happens. Two-pole out of range. Doesn't tell us which ratio of its quantity on Twitter compared to its quantity on. Let's comment these out for a second, or at least the last one, because that's what it's saying is wrong. Okay, the oh, I see. So it wants this first value, it wants to be the emoji name, which is the first row, right? Or the first element in the row, row 0. And then we need another value, which is the ratio that we actually calculated. All right, so let's see if that works. Yeah, it looks weird though. Maybe it looks better if you have a wider screen. Check the table formatting. Well, you did the formatting for me. Why is it not working? Emoji name grinning. That looks right. Oh, I printed ratio up here, huh? We shouldn't add extra print lines in there. Okay, now it looks better. Aha! All right, next. We've obtained bizarre results. As you can see, many values have deviated by the mean ratio by 100 times, but the recycle emoji stands out as the most, with its outstanding popularity on Twitter, about 16 times more frequently than on Instagram. We've studied this phenomenon and discovered that posts featuring the recycle emoji may often be manufactured automatically and possess a meaning that differs from its initial intent. You read more about it on article Medium. So we've arrived at the following conclusions. Emoji statistics have heavy tail because people like variety. We can't confirm or disprove our hypothesis. Simply looking at the tables and calculating the mean values isn't enough to come to definitive conclusions. We're going to have to apply a specialized method for analyzing data in tables. Next. So I'm going to end that here. That was the end of the list section. It just took a lot of time to do that, so we'll stop there before we go into more datas and tables. Thanks. Talk to you guys later.